In this unit, we're going to be taking a look at special products of binomials, really just kind of special polynomials or special trinomials and binomials that we're going to see here. And there's going to be a relationship that you're going to see going on. So the first one is called difference of two squares, and you can see right here that a squared minus b squared is equivalent to a plus b times a minus b. And so that's a little shortcut, but first we're going to kind of just see where that shortcut comes from by doing things the long way, by using that FOIL method and seeing how things cancel out and leave us with something simple such as a squared minus b squared. Once we get the hang of that shortcut, we can apply it to more complex polynomials. So that's the whole point of 1.3.1, and you can see it in our objective to observe the pattern of difference of squares by distributing using the FOIL method. So we're really just going to be looking out for a pattern right now and seeing what happens. So what I'm going to have is we're going to have x plus 3 times x minus 3. So when we distribute this, x times x is x squared. X times negative 3 is negative 3x. And then 3 times x is plus 3x. And 3 times negative 3 is negative 9. Now what I want you to see here, and let me erase this actually, and I'm going to rewrite this just so it sticks out, including the signs. This is plus 3, this is minus 3. Everything looks the same except this one's plus that number, this is minus that number. Now it has to be the same number in order for it to be difference of two squares. So what we're going to see here is that x times negative 3 is negative 3x, right? And then plus 3x, using a bit of Christmas colors here. I might change that for the next one because it's not really Christmas time. But right here, what's going to happen to these? They're the same number, just opposite. So negative 3x plus 3x, aren't those just going to cancel out? Negative 3 plus 3 is 0, isn't it? So we're going to be left with x squared minus 9. So this happens. Look at that setup. Look at this setup right here. 2 plus 7x, 2 minus 7x. Just the only thing that changes is the opposite of the two signs. And look at the answer. It ends up this nice simple binomial. It has that x squared and it has our constant term. So it has our leading and constant terms. So you could see this rule right here. When you see this, they're the same things in each binomial, just one's a plus, one's a minus. End up with a very simple polynomial at the end when you write it in that form. So there's another one that you guys can try, very simple. I'm going to go through a little bit more complicated one, but we're going to see that same exact pattern. And as you get used to these patterns, you can actually just shortcut it once you do enough of them. And I'll show you what I mean. I can assume right now that this is going to be 4, because 2 squared is 4, and then 7x squared is 49x squared. And it's different to two squares. This is always going to be a minus sign. And you'll see that right now. So let's just go ahead and do it the long way. And yes, the long way is always an option that's available. If you don't get comfortable with the pattern, you could do it the long way. So 2 times 2 is 4. And then we have 2 times negative 7x is negative 14x. And then 7x times 2 is positive 14x. And then last, 7x times negative 7x is negative 49x squared, because 7 times negative 7 is negative 49, and x times x is x squared. I just forgot the squared there. And you'll see right here, negative 14x plus 14x, those are just going to cancel each other out and leave us with 4 minus 49x squared. So really, do it the long way when you go through this assignment, because that's going to help you appreciate the shortcut, but not just appreciate it, but also understand it. And it's going to help you master and realize why this is just 2 squared and that's going to be 7x squared, and why this is always negative. It's just going to help you understand it as you practice it more and more.